In this video, we're going to start looking at coordinate geometry. To begin with, we're going to focus on the equation of a straight line. Before I really get into the topic, I want to give a tip or one piece of advice, and that is to draw things. As I say, if in doubt, sketch it out. To begin with, that might seem quite tedious, but as we go on, the more challenging questions become a lot more straightforward once you have some visual representation of what's going on. So let's go ahead and start with the basics. What I'm going to do is draw a set of coordinate axes. So we've got the x-axis and we've got the y-axis. So x is just here, so let's put this on. We've got x and we've got y. We're going to look at a range of horizontal and vertical lines. This is a vertical line right here, and here's another one. So we could label these up, and we could have, for example, now that this is x is equal to 5, and then this one right here, we could say x is equal to 8. I've not plotted these, I've just given some idea of where they are. So if we have vertical lines, x will be equal to some value. If x is equal to 0, that gives us now the y-axis. Let's go ahead and draw some horizontal lines. Let's put one just here, let's put one just here. We could say now that this one right here, we've got now y is equal to 3, and this one right here, let's say y is equal to -4. If we have y is equal to 0, that gives us now the x-axis. So these are horizontal and vertical lines, and it's briefly recapping what you would have learnt lower down the school. When we look at the equation of a straight line, we can write this in two different forms. The form you're probably familiar with is y is equal to mx plus c, where m is the gradient and c is the y-intercept, or where x is equal to 0. So this is the first form that we will deal with. The second form, which you may not yet have seen, is ax plus by plus c is equal to 0, where a, b and c are integers, so they're whole numbers. In the video, we will look at converting between the two and looking at different features. Sometimes it's easier to write it in this form, sometimes it's easier to write it in this form, and we will look at those different situations. Let's go ahead now and look at straight lines in the form y is equal to mx plus c. So we might have now y is equal to 2x plus 1. This tells me it's got a gradient of 2 and a y-intercept of 1. So if we looked at that, we could go ahead now and graph that. So I've got now y is equal to mx plus c. So the gradient is going to be 2, which is going to look like that, and the y-intercept is going to be 1. So we can see now the y-intercept here is 0, 1, and it's got a gradient of 2. That means if I just come in and zoom in, it goes up 2 for every one it goes across. It goes up 2 for every one it goes across. When we're talking about the gradient, we're talking about the change in y over the change in x. So the change in y is 2, the change in x is 1. You might hear that being said or referred to as the rise over the run, or dy over dx. I prefer the change in y over the change in x. So this now is the straight line, y is equal to 2x plus 1. If I had 2x plus 2, we would simply now move the graph up by 1 unit. So we can see now the y-intercept is going to be 2. That just means when x is 0, y is going to be equal to 2. We can see that those two lines were parallel as the gradients were going to be the same. So with this one, I've got y is equal to px plus q. So all I'd do on this one, if I wanted now a parallel gradient, it would be now a 2. That gives me the 2, and we can see moving this up and down, changing the values now will give us the y-intercept. So that one right there, I've got now y is equal to 2x minus 2. We could look at y is equal to 2x plus 3 and keep going with those. So this now is of the form y is equal to mx plus c. Y is equal to x minus 3, gradient of 1, y-intercept of minus 3. Y is equal to 1/2 x plus 5. We've got a gradient of 1/2 and now a y-intercept of positive 5. Sometimes we might have the form y is equal to 4 minus 3x. If we just rewrite that, y is equal to minus 3x plus 4. We've got a gradient of minus 3 and a y-intercept of positive 4. Okay, let's look now at the equation of a straight line in the form ax plus by plus c is equal to 0. So ax plus by plus c is equal to 0, where a, b and c are integers. So these are whole numbers. So if we look, we might have 2x plus 3y minus 2 is equal to 0. When we're thinking about the gradient of this line, we can rearrange it to put it in the form y is equal to mx plus c. Often if we just rearrange it, it will give us some idea. So if we look at this one, I could write now that 3y is equal to minus 2x. So I'm simply subtracting the 2x from both sides and adding 2. If I divide through by 3, we've got now y is equal to minus 2/3 x plus 2 over 3. So we got a gradient of minus 2/3 and we got a y-intercept now of positive 2/3. If we had now, for example, let's go for 5x minus 4y minus 3 is equal to 0. We could write this now, adding the 4y to both sides. 5x minus 3 is equal to 4y. And then dividing both sides now by the 4, we would have y is equal to 5 over 4x minus 3 over 4. So we've got a gradient of 5 over 4 and a y-intercept of minus 3/4. Let's now go ahead and look at finding the gradient of a line or a line segment. When we're talking about a line segment, that just means it's forming part of a line. So for example, if we had the line y is equal to 2x plus 1, we might have a part of that line. And often that will be referred to as AB, and it'll just be 2 points on the line. So let's look at finding the gradient. We write the gradient now as m. M is the change in y, so let's write this in, the change in y over the change in x. So the change in y over the change in x. Formally, this is written now, m is going to be y1 minus y2 over x1 minus x2. And we need to be consistent with these. Now, I think that's a little formal, but as we go through, it should make sense of what we've got. So let's look at 2 points on now the coordinate axis. So we've got, or the coordinate plane. We've got now 4, 7, and let's go for 10, 9. What we want to do is find the gradient of the line segment joining these points. So what I'm going to do is just get some idea of what's going on here. We've got 4, 7, let's just go here. So that's going to be, let's say that's 4, let's say that's 7, and then we got 10, 9. So let's say that's going to be just here. Now that isn't a massively accurate drawing, but it just gives me some idea. So the first thing I can see now, if I wanted, I could call these 2 points A and B. So we've got now A, which is this one right here, and we got B. We can see straight away that we have a positive gradient. If we got a positive gradient with our line, we're going to start now in the bottom left-hand corner and then go up out the top right corner. So with this one, if you like, we're coming through this third quadrant and we're going out the first. If this was negative, we would be going the other way. So let's just plug these values in. So we've got y1 minus y2. Now when I look at these, I've got now these two values of 7 and 9. It really doesn't matter as long as we're consistent. So what I'm going to say is the gradient of this line is going to be 9 minus 7. So 9 minus 7 over 10 minus 4. So all this is the change in x over the change, change in y over change in x. So let's see what we've got. So this one is going to give me 2, 9 minus 7 is 2, and then 10 minus 4 is going to give us 6, and we just simplify that to 1/3. So we're telling now, we're seeing from this that the change in y is 1, the change in x is 3. So this has a gradient of 1/3. It goes up 1 for every 3 it goes across. Now I could have gone the other way. Let's do it the other way. I could have gone now 7 minus 9 over 4 minus 10. I need to be consistent. I can't do, for example, now 9 and swap these over. I can't just decide that I'm going to do 1 and then swap them. We have to be consistent. So it's 9 over 7 and 10 over 4. Let's write this one out. So what we're going to have, we're going to have minus 2 over minus 6, which is going to give me positive 2 over positive 6, as the negatives are going to cancel out, and we're going to end up with a third. So it really doesn't matter which way round we do it. So that's what we end up with. And as stated, you might hear this being called the rise over the run. That's a little informal, but kind of gives us some idea. Okay, let's look at another one. Let's go ahead and look at another gradient. So what we've got then are 2 points. So we're just plotting 2 points. Let's go for 6, let's do 6, 1. So let's say we've got now P, and P is going to be 6, 1, and then Q, let's go for 2, 5. Now P and Q, A and B, are often used in coordinate geometry. So 6, 1, let's put this just here, that's going to be our 6, 1, and then we're going to have now on the other one 2, 5. So 6, 1 and 2, 5. So here we go, let's put this on, let's put now 2, 5, and then let's put 6, 1. So this time, getting some idea, we should recognise that this is going to be negative. So we might have a line that passes through these 2 points. So instead of, this is just a line segment, PQ is a line segment, and it's on this line right here. Okay, so let's look at the gradient. It's a change in y over the change in x. So I could, at this stage, do 1 minus 5 over 6 minus 2. So 1 minus 5 over 6 minus 2, or I could have done 5 minus 1 over 2 minus 6. So this is going to give me now, let's just put m, that's a gradient. M is going to be minus 4 over now, and that's going to be 4. So that gives us a gradient of minus 1. If we look at this one, now m is going to be 4 over minus 4, and we can see that that's going to give us minus 1. So that's the gradient right there. It's the change in y over the change in x. So this is telling me that it's going down 1 for every one it goes across. So if we looked at this now, what we're doing, we're going down 1, so down 1 for every one we go across, we're going down 1 for every one we go across, down 1 for every one we go across, and so on and so forth. So we can see now that if you were going down, it's just going to have a gradient of minus 1. Okay, let's look at another one. Let's say we've got the points A and B. So let's take A, let's take A to be minus 2, let's take B to be now, let's go for 0, minus 8. So what we've got now are some negatives. So let's go ahead and just get some idea of what's going on. So the first one, we got minus 2, 0, okay? So let's have a look at that one. That's going to, let's put that just there. That's going to be minus 2, 0. And then we've got now 0, minus 8. Sorry, to be down here, won't we? 0, minus 8. So what we've got here now are these two values, and we can draw now a line segment. So this would be a line segment. It's just part of a line. So what we want is the gradient. So we're going to say m, and what I'm going to have is the following. We need to be careful. I'm going to have 0. This is the change in y minus 8 over the change in x, which is going to be minus 2 minus 0. So what we end up with is 8 over now minus 2, which is going to give us a gradient now of minus 4. Be very careful. If you'd gone the other way, we could have said m was going to be minus 8 minus 0 over 0 minus 2. So we end up now with minus 8 over positive 2, which again just gives us now the minus 4. So this one, now if we look at this, essentially this is saying minus 4 over 1. So this is going down 4 for every one it goes across. It goes down 4 for every one it goes across. This is the change in y over the change in x. So that's looking at finding a gradient, and do be careful now with those negative signs. And as you can see, just by a quick sketch, we can see clearly that that gradient is negative. If it had been going the other way, we would have had it a positive. So if you come up with a positive value, a positive gradient will look like that. Negative gradient will look something like so. Okay, let's move on now to the equation of a straight line. And we're going to look at this initially in the form y is equal to mx plus c. And then I'll put them in the form ax plus by plus c is equal to 0. For the equation of a straight line, all we need are two things. we need a gradient and a point on the line, or a point the line passes through. So let's look at an example of that. Let's say we've got now a gradient, and we're going to say the gradient is 2 and a point on the line is now 3, 2. What we want is an equation of the line that passes through the point 3, 2 and has a gradient of 2. There are two different ways that you can do this. One is to use the form y is equal to mx plus c, and the other is to use y minus y1 is equal to m the gradient x minus x1. It's entirely up to you which you use. I prefer this one, and I'm going to default to using this one later in our work. It's entirely up to you. I'm going to show you the first view working both ways. Ultimately though, we'll put it in this form. So let's start by using now the form y is equal to mx plus c. So what we're going to do are plug in these values. So we can see now that the y coordinate is 2, then that's going to be equal to m, which is going to be 2, and we're going to have the value of x, which is going to be 3, and then we add now c. So with this method, what we're looking to do is find the y-intercept, and that's the value of c. So what I have is 2 is equal to 6 plus c, so we can see subtracting 6 on both sides, c is equal to minus 4. We can now put this back in the form of y is equal to mx plus c, as we've solved and found for c. We've got the gradient of 2, so it's 2x minus 4. And that is now a straight line passing through this point right here with a gradient of 2. So what we've done, we've solved for c and then plugged it back in. This is now in the form y is equal to mx plus c. This method is slightly different. So let's take exactly the same information and sub it in. I actually prefer this one. So what we do is y minus the y coordinate, which is going to be 2, is equal now to m, which is the gradient, which we know is 2, and then x minus x1, which is the x coordinate. So y1 is 2, x1 is 3. At this stage, we've got y minus 2, expanding the brackets is 2x minus 6, and then we simply need to add 2 to both sides. So y is equal to 2x minus 4. Exactly the same. So that's what we have. So that's now written both ways in the form y is equal to mx plus c. So let's go ahead and look at some more examples of those. So what I'm going to do is just write now some points that a line passes through and a gradient. So let's take now the gradient to be minus 1, and let's take a point on the line. Let's say we're going to have some point. Let's say that this is going to be 5, minus, let's go for 5 minus 2. So if we use y is equal to mx plus c, we're going to have the y coordinate, which is minus 2, is equal to m, which is minus 1, multiplied by the x coordinate, which is going to be 5, plus c. So all I'm doing is using this form right here to find c. So I'm going to add 5 to both sides, and that's going to give us now c is equal to 3. So putting this back together, y is equal to mx. Well, m is minus 1, so we would just write minus x plus 3. Now do be aware that this could be written as y is equal to 3 minus x. And don't be alarmed if you see it in this particular form. If we had used this approach right here, we would have had the following. We would have had y minus 2 will be equal to minus x minus 5. So we're going to have on here y, and let's just go ahead and do this. We're going to have y, and this is going to be now plus 2. We got minus minus, and that will be equal to minus x plus 5. Subtracting 2 from both sides, y is equal to minus x plus 3, or if we like, y is equal to 3 minus x. So that can be done either way. Let's do a couple more to get used to them. So let's go for now the gradient. M is going to be equal to 1/2, and let's take a point. Let's go for minus 2, and let's go for 6. So y is equal to mx plus c using the first method. So we've got the y coordinate, that's 6. We've got m, the gradient, which is 1/2. We've got minus 2, which is the x coordinate, plus the c. So we've got 6 is equal to now minus 1 plus c, adding 1 to both sides, c is 7. So we can put this back as y is equal to 1/2, that's the value of m, we've got our x plus 7, and that is the line. Y minus y1 is equal to m, the gradient, x minus x1. So subbing in the values, y minus 6 is equal to 1/2, and then we'll have x minus minus 2. So what we've got then is y minus 6 is equal to 1/2, then we'll have x plus 2. Y minus 6 is equal to 1/2 x plus 1, and then add 6 to both sides. Y is equal to 1/2 x plus 7, exactly the same. So there we go, that's what we end up with, and that's in the form now y is equal to mx plus c. Okay, let's now look at finding the equation of a line given 2 points. So what we might have now, let's have a look. Let's say we were given now 2 points on a line, and we're asked to find the equation or an equation. When we're asked to find an equation, that means we can put it in the form that we like. We can have y is equal to mx plus c, or ax plus by plus c is equal to 0. So let's take 2 points. Let's go for these ones right here. So what we want to do now is find an equation of a line passing through these 2 points. So let's just have some idea of what's going on. We've got minus 4, 3 and 2, 7. So let's put minus 4. So minus 4, 3, let's say that's going to be just here. And let's say we got 2, 7, which is going to be, let's say that's going to be just there. So straight away we can see that we're looking at this right here. Let's do that. We're going to have some straight line, and it's going to pass through these 2 points. So the first thing that we need is a gradient. All we need for the equation of a straight line are 2 things: a point that it goes through and a gradient. So let's look at the gradient. The gradient is the change in y over the change in x. So 7 minus 3 over 2 minus minus 4. So we've got our gradient. That is going to be 4. 7 minus 3 is 4 over 2 plus 4, which is 6. So we could write this now as m is equal to 2/3. So we now have a gradient. We have a choice of points that it goes through. We can choose either of these to put in the straight line. It really doesn't matter. Often one will be easier than the other. So for example, if you had 0, 1 compared to minus 1/5 and positive 2/8, we quite clearly put it through the easy one. So let's use the form y is equal to mx plus c. So what we're going to have then, I'll take this one right here. We're going to have the following. We're going to have 7 will be equal to 2 over 3. Then we're going to have the x value. The x value is going to be 2 plus c. So what we've got then is the following. We've got 4/3, and I'm just going to write this as thirds. So we've got 21/3 is equal to 4 over 3 plus c. So subtracting 4/3 from both sides, we've got 17 over 3 is equal to c. So we can write this as y is equal now to 2/3 x plus 17 over 3. So as you can see, they're not always going to turn out to be nice, particularly nice values, but it works anyway. Let's go for the other approach. Let's say y minus y1 is equal to m, the gradient, x minus x1. I feel a lot more at home using this method, but it's entirely up to you. So y minus 7 is equal to the gradient, which was 2/3. We've got x minus 2. So on here we've got y minus 7 is equal to 2/3 x minus 4 over 3. And then all we're going to do is add the 7 to both sides. So y is going to be 2/3 x minus 4 over 3 plus now the 21 over 3, which is 7. And we get exactly the same. Y is equal to 2/3 x plus 17 over 3. Okay, so that's finding the equation of a straight line given 2 points. Now this, as we currently stand, is written in the form y is equal to mx plus c. I have to say, I'd actually prefer to write that as ax plus by plus c, where a, b and c are integers, and set that equal to 0. Especially if we're at this stage right here. Now, if I picked it up at this stage, and this is why I prefer this approach, And I'll just rewrite it. Let's say we got to this stage right here. Y minus 7 is equal to 2 over 3 and then x minus 2. If I multiply both sides of the equation by 3, I've got 3y minus 21 will be equal to 2 lots of x, and then we're going to have now minus 4. So at this stage we can see it's quite easy to rearrange it and we're not dealing with fractions. So 0 is equal to ax, and then we're going to have plus by, which is going to be minus 3y, and then we're going to have now, adding now the 21 to both sides, plus 17. And that is in the form ax plus by plus c is equal to 0. And you can see all I've done essentially is multiplied this by 3 and subtracted 3y from both sides. I just think at this stage it's slightly easier to deal with. And again, graphing lines like this become quite straightforward. Now, if we wanted to graph this, what we could do is the following. And this is quite a nice little sort of quirk of this. And we've looked at this in the graph in curve sketching when we looked at straight line equations. Let's say we wanted to just go ahead and graph this. What I would do is the following. I would set x to 0 and y to 0. So when x is equal to 0, what we're going to have then is the following. We're going to have 0 is equal to minus 3y plus 17. So if we look at this right now, what we've got is the following. We can say that y will be equal to 17 over 3. So this is going to, let's just put this on right here. So this is going to be 0, then we're going to have 17 over 3. Okay, now that was setting x to be equal to 0. If we set y equal to 0, we've got 0 is equal to 2x plus 17. So we can see that x would be equal to minus 17 over 2. Now, minus 17 over 2 is going to be somewhere up here, okay? So let's go ahead and put that on. So that's what we'd have. And we'd have now minus 17 over 2, which is 8.5, comma 0. And we can just go ahead and draw that straight line. So another advantage of this is you can set those equal to 0 and get some idea of the line. And of course, if you wanted to go ahead and do that, you could just say that 2x minus 3y plus 17 is equal to 0. And that now gives us the straight line in that form. Okay, let's look at doing another one of those. Let's say we've got another point. Let's say we've got 3. Let's take minus 2. Let's say we've got now 18 comma minus 5. So what we want is an equation now that passes through these 2 points. So what we need then is a point that it goes through, and we got these, and we need a gradient. So m, the change in y over the change in x, minus 5 minus minus 2 over now 18 minus 3. So is this quicker? Is it better to do it this way? Well, you can argue each way. We're going to end up with a negative in the numerator. We've got now minus 5 minus minus 2 is minus 3. And then we've got now over 15. So what's that going to be? That's going to be minus 1/5. Just dividing top and bottom by 3. So this now is my gradient. At this stage, I can choose either one of these. Now, looking at this, it's entirely up to you. You can use either. I'm looking here and thinking, well, that's a bigger number. I can't really be bothered to deal with that. So let's go ahead and use this one. So what we've got is y is equal to mx plus c. So subbing in the values, we've got now minus 2 is equal to minus 1/5. Then we've got the value of x, which is going to be 3 plus c. So let's write this now as fifths. So we've got minus 10/5 is equal to minus 3 over 5 plus c. So adding that to both sides, we get minus 7 over 5 is equal now to c. So rewriting the line, y is equal to minus 1/5 x minus 7 over 5. And that gives us now a straight line. So again, not very nice, but it gives us a chance to practice. Okay, y minus y1 is equal to m, the gradient, x minus x1. So, using exactly the same coordinates, I've taken now the 3 and the minus 2. We're going to have y minus minus 2 will be equal to minus 1/5. That's a gradient. And then we'll have x minus 3. So, we'll have y plus 2 is equal to minus 1/5. Then we're going to have x minus 3. At this stage, I'm going to multiply through by 5. 5y plus 10 will be equal to minus x plus 3. So let's put this now in the form ax plus by plus c is equal to 0. So I'm going to add x to both sides. X plus 5y subtracting the 3 plus 7 is equal to 0. So that's now another form that can be written in, and you could see if we went ahead and did that, multiplied it through by 5, then added x and added 7, we'd have exactly the same. So to be flexible now, it's important that you can work through these. Okay, now another question that we might be asked is a certain point on either of these lines that we've done? Let's take the point now and let's see if the point 1, 2 lies on any of these lines. So how would we do that? Well, let's consider now a way that we could sub these in and find out. So let's take this particular form. If I now say x is equal to 1, that gives me now here 1 plus 5y plus 7 is equal to 0. So if I subtract 8 from both sides, we've got now 5y would be equal to minus 8. So we can see now that y is equal to minus 8 over 5. So that point is not on the line. And we can use either of these particular forms to just find out if points are on the line. So if you ask, is this point on there? And perhaps even if you sketch this up, you'll see quite clearly it's not. And with this form right here, it's quite easy to go ahead and sketch that. So let's just do that. Let's go ahead and just sketch this line up. So if we now set y equal to 0, if y is equal to 0 in here, x is going to be minus 7. So let's do that. Let's put that point on. So we've got now minus 7, 0. If we have now y is going to be equal to 0 on here, so if x is going to be equal to 0, 5y plus 7 is equal to 0. So we could say that y is equal to minus 7/5. And that would be just here. So we've got 0, minus 7 over 5. And straight off we can see that 1, 2 is not going to be on there. So that's what that line would look like, something like that. Okay, and that's what we'd end up doing, and we'd just label that up. Okay, let's start working and extending our understanding of straight lines and start to look at the kind of questions that we might be asked. What we might be given now is a line. Let's say we got y is equal to, we'll go for 6 minus 3x. We'll be told something along the lines of, now this particular line crosses the x-axis, so let's write this here, x-axis at A and the y-axis at B. And what we might be asked to do is find, for example, the area, let's write this here, the area of triangle AOB, where O is the origin. Okay, so O is the origin. So let's go ahead and look at what we've got. What I'm going to do is the following. Just going to sketch this up. So let's find the area. So we've got y is equal to 6 minus 3x. So if we consider now, if x is equal to 0, so what we've got, if x is equal to 0, then y is going to be equal to 6. So what I'm going to have is this point right here. This will be 0, 6. So y would be equal now to 6. If y was equal to 0, what we would have at this stage now is 6 minus 3x is equal to 0. So rearranging, 3x would be equal to 6, and then we would have now x is equal to 2. So what we'd have then is this point right here, and that would be 2, 0. And again, you'd need to show your workings in that just to make sure the examiner knows what you're doing. So what we've got then is this. Now let's just go ahead and draw this. We've got this straight line passing through these 2 points. In later videos we'll spend a lot more time looking at these exam style questions, as some become really quite interesting and at times quite tricky. So what we've got then is the following. This is going to be A, this is where it's crossing now the x-axis. This is going to be B, and this is going to be the origin. These now are perpendicular. The axes are perpendicular, as we know. So what we have here is a little triangle. Now if we go ahead and just sketch up this triangle, all we've got, let's choose a different one. Let's choose a right angle one, that one. Okay, what we've got here now, if we just draw this, is a base, and the base is simply the x-coordinate. That's going to be 2. We've got a height of 6. So the area is going to be 1/2 multiplied by the base multiplied by the height. So we can say that that will be 6 units squared, or 6 squared units. And that shows us a typical kind of straightforward little problem that we might have to solve using now the equation of a straight line. Okay, let's look at another one. Let's go for something else. Let's say we've got now y is equal to, let's go for 2x plus 1, and y is equal to, let's go for minus 3x plus 6. What we might be asked is to find the distance from the point where these two particular lines meet and now the distance from that point to the origin. So let's say these meet now, let's say these meet at, let's say they meet at P, and what we might want to find out is the length now of OP, where O is the origin. So let's go ahead and look at this, and a quick sketch is not going to hurt. Let's just think about what we're going to have. So the way I'd like to think about this now, and again, we could just go ahead and draw a quick sketch, don't really need to. 2x plus 1 is going to look something like so. Then minus 3x plus 6, let's go ahead and do that, is going to be looking something like that. That's not brilliant, but it just gives us some idea. We can see that this is a steeper line. So what we're looking at then is the point of intersection, which we'll say is just here. So what we've got then, we've got 0, 1 here. We've got now this point right here, which is going to be 0, 6. Of course, we could find now where each of these cross the x-axis. That's where y is equal to 0. So if y is equal to 0, this point right here is going to be minus 1/2, 0, as 2x plus 1 would be 0. And if y was equal to 0, we would have 3x is equal to 6. So we'd have now this point right here, x would be equal to 2. So what we're looking for then is this point of intersection, and we're going to look at the distance from the origin to that point, which is just going to be a straight line. So let's go ahead and do that. So let's find the point of intersection. If y is equal to 2x plus 1 and y is equal to minus 3x plus 6, then 2x plus 1 is equal to minus 3x plus 6. Okay, let's add the 3x to both sides and subtract the 1. We've got 5x is equal to 5, so x is equal to 1. So that works out quite nicely. Subbing into either of these ones, that's going to be the easier one. Showing full workings, y is going to be 2 lots of x plus 1. So we've got y is equal to 3. So this point right here, we're going to have now 1, 3, and that gives us the point P. So we found the point P. So all we're looking for now is the distance from the origin. In a later video, we're going to look at the distance formula. The distance formula is simply glorified Pythagoras. There's no more to it. So if I just draw what we've got this situation right here. Let's go ahead and do this. And this is really a rough sketch. It gives us no real obvious showing of the magnitude of each of these numbers, but it goes across 1 and up 3. So just using basic Pythagoras, this will be the square root of 1 squared plus 3 squared. So we can say that that is root 10 units, and that is an exact answer. So we can say that OP would be equal to root 10. Now all I've done essentially here is use the distance formula, and we'll come on to this later. The distance formula is x1 minus x2 all squared, plus now we've got y1 minus y2 all squared. It's Pythagoras. Just consider what I've done here. I've done it now, this point right here, this is 0, 0. I've done 1 minus 0 squared plus 3 minus 0 squared, and then just calculated it. If this had been some other point, we just would have done that. So if it asks a distance from the point here to here, it'd be 1 minus 0 squared, 3 minus 6 squared, add them together, square root them. So that's another nice little question, and as stated, later on in the videos we will look at some exam style questions on those. So hopefully that's given you a brief introduction to straight line graphs in the form y is equal to mx plus c and ax plus by plus c is equal to 0, where a, b and c are integers. For the equation of a straight line we need two things: a point that it goes through and a gradient, and we can find that. We've looked at different ways of finding that. We've looked at the alternative ways of working out the equation of a straight line. We could use y is equal to mx plus c, solve for c and plug that back in, or use y minus y1 is equal to m, the gradient x minus x1. It's entirely up to you. I prefer the second method. We've also then looked at finding certain points on the line. We've looked at whether it passes through a point, and we've also gone on to look at some basic applications of this, and this is where it comes back to my suggestion of sketching everything. So, brief introduction or revision of straight line equations, and in the next video we will move on to parallel and perpendicular lines.